Welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mascot this side. So in this video, going to discuss another topic of linked list, that is merge to sorted list. The question says that you have been given list 1 and list 2, and it has been provided that both these links are sorted. So you can see 1, 2, 4 sorted linked list, 1, 3, 4 sorted linked list. Now you have to merge them up and form a sorted linked list. Now merge them up and form a one sorted. These are two sorted linked lists, and you have to form one sorted linked list. So you can see the nodes are mentioned. Purple nodes are from the list number 2, red nodes are from the list number 1. So this 1 is equals to 1, right? So I can mention any of them. I mentioned the purple one first. Okay, 1. After this 1 should come in a sorted order. Okay. After that, this 2 should come in a sorted order. Okay. After this, 3 should come in the sorted order. All right. Then this 4. Okay. Then this 4. Okay. So if you are able to see 1, 1, 2, 3, 4, 4, it is a sorted order. It is a sorted order. There is no problem in understanding that. Okay. I hope the input and output schema is clear to you, right? And now, what about the brute force approach? So brute force approach is actually very simple. What does the brute force approach say? Brute force approach says use a vector. Okay, I will use a vector, that is list. I will make an v vector. I will push all the values of the nodes. I will push 1 into it. I will push 2 into it. I will push 4 into it. Then I will push the list number 2 also in it. That is 1, 3, 4. Now, if I sort this vector will do something like 1, 1, 2, 3, 4, 4. 1, 1, 2, 3, 4, 4. Now I will simply merge the linked list. That is, I will make a new linked list which looks something like 1, 2, 4, 1, 3, 4. That is very simple. I just have to attach this tail with this head, right? No problem in that. Okay. After that, I will put my temp here and my I here, and I will start filling values. I will change the temp value to the ith value, that is 1. It will change to 1. It is already 1. I will move my temp forward. I will move my I forward. Again 1. I will change this to 1. Okay, I will move my I forward. I will move my temp forward. This is 2 now. I will change this to 2. Temp here, I here. I will change this to 3. Temp here, I here. I will change this to 4. Temp here, I here. I will change this to 4. This is already 4, but again changing it. Okay. After this, the linked list looks like exactly the same, right? And that is your answer. You can just simply return this head. Okay. But isn't this cheating? Isn't this cheating? This we solve it like a vector question, right? We solve it like a vector question. We sorted the vector and then put the values. That is something called cheating. But still, the answer will come out to be true. What is the time complexity here? The time complexity here is I'm using O of n time to put all the values into the vector, right? After that, O of n log n time, where n is sum of both the elements, right? Sum of n1 plus n2, right? Okay. N log n to sort the vector, and after that O of n to put the values back, right? So it is actually evidently O of n log n. But what is the space complexity? So I'm actually using an extra space of n to store all the elements, right? That is something unfair. I don't have to use O of n if the given linked lists are already given to me sorted. If the linked lists are given to me sorted, I can actually do that without O of n extra space, and O of n log n time is also pretty much for that. I'm challenging you to do it in O of n time, O of 1 space complexity. That will be my optimized approach. That will be my optimized approach. How? Let us see. So this is the configuration given to me. My list node 1 is starting from here. My list node 2 is starting from here. Alright. I will have to make a linked list new. I am saying that if the data in the linked list 1 is less than data in the linked list 2, right? I am saying if L1's value is less than equals to L2's value, in that case, it is pretty sure that this node will come before this node, right? In this case, both are equal, so I am proceeding in the L1. I am giving the edge to the L1, right? I'll say push this node into the linked list. That is, my head will become 1. And after the node you push, you will move it forward. L1 comes here. L1 comes here. Okay. After L1 comes here, I will see 2 and 1. I will compare 2 with 1. I will see 1 is less than 2. Okay, so move the L2 node here. That is, this will come here. And move L2 forward. L2 comes here. 2 and 3, which is shorter? 2 is shorter. Move L1 node here, right? And move L1 here. 3 and 4. 3 comes here, right? L2 comes here. Now 4 and 4. Again, I am giving the edge to the L1. Both the nodes are same. You can go with any one. 4 comes here. L1 goes to null. Now, the only nodes remaining are 4. Suppose the linked list would have been something bigger. It would have been 5, 6 here. I am saying if L1 all the nodes are finished within the sorted order, can I say the remaining nodes are already in sorted order? The remaining nodes are already sorted because the linked lists are given to be sorted, right? So I can actually do is I can actually attach this node with L2, right? With the remaining L2 because L2 is already here. With the L2 is already here. So my algorithm is stating me something like this. My linked lists are 1, 2, 4, 1, 3, 4, right? I will create a dummy node. Let us say the dummy nodes create a value 1. This is my head right now. I will delete it at the time of returning and I will keep my temp here. Now, my L1 is here, my L2 is here. My condition says pick the value which is least. L1 is least, both the values are same, but I'm giving the edge to the L1, right? L1 is least. So what do? I will do the series of steps, that is temps next equals to L1. That is temps next equals to L1. This node is getting connected to this. So something like this. Okay. Now I will say L1 equals to L1's next. L1 equals to L1's next. Move L1 from here up till here. Okay. Temp becomes temps next. That is move temp from here and move it here. Okay. Now this node and this node are actually same, right? I want to break this connection so as to remove this part out of the linked list, right? I will say now this is temp, right? So I will say temp next equals to null. That is this connection is broken off and this node is no longer a part of the linked list, right? Now in this I did it for L1, but the same goes for L2. Same goes for L2. Okay. After this, the series of steps will continue. I will attach 1 here. I will move L2 here. This node will no longer be remain apart, right? I will attach 2 here. I will attach 3 here. I will attach 4 here, right? After attaching this 4, my L1 was here, right? My L2 is also here, right? These two nodes, all the nodes are actually not a part of it, right? My L1 is here. My L2 is here. L1 goes to null, and this 4 will get attached, right? This linked list is finished. This linked list is finished. Now I will have to attach this node. I can simply say my temp is here. I will say temp next equals to L2, right? This is my case. This is my case. What I'm doing is my algorithm will look something like this. Up till both L1 and L2 are not null, right? Up till both L1 and L2 are not null. Merge by comparing their values. Merge by comparing their values. Second option says up if any one of them becomes null, any one of them becomes null, attach your temp to the one which is not null, which is not null. Now after all the steps we mentioned above, the linked list, the final linked list would look something like this: -1, 1, 1, 2, 3, 4, 4. Okay, and I got the sorted linked list. This is my sorted linked list. I want this as my answer, right? I have my head here. Now it is very easy to delete the beginning position. I will delete this node. How will I delete this node? I will say my new head equals to heads next. My head comes here. My new head comes here, right? Now I will say delete your head. Delete your head. The memory you use, clear it out. Cleared. Okay. After that, I will say return your new head, and you can see this is actually your linked list. You wanted your answer, right? New head. Right? Right? Okay. The pseudocode is mentioned below, right? Just take a look at it. Alright guys, so you can see the pseudocode here. We created a dummy, we assigned this dummy. Then this is for the case when both of them are not null. After that we will attach the temp to the one which is not null, and then return your new head. The code for the new head is this, the 3 steps. Alright, let us move to the coding area, right? I hope you are clear with the question. I hope that is clear to you, right? What is time complexity, by the way? So you can see we are actually moving O of n time only and O of n operations only, right? O of n operations only. Maybe even less if this is considered as only as one operation, right? Okay. Let us try to make this code work in the coding area. Alright guys, so here we are, and before starting to code I would like to request you to please subscribe to my channel because it gives me a lot of motivation, right? Okay, starting with it. So list node star, I will have to mention list node star. I will create a dummy node. Let us create as a head only, right? Head equals to new list node with value -1, right? And similarly list node star temp equals to head. Now that we will write the code when both of them are not null, that is list 1 and list 2, right? What do? We will say if the value in list 1 is less than equals to value in list 2. In that case, what do we say? We say the following steps, that is temps next will actually become equals to list 1. Now list 1 will actually change to list 1's next, right? Temp will change to temps next. Now I will make temps next as null. And same for the list 2, that is in the else operation I will say temps next is equals to list 2, list 2 equals to list 2's next, and temp changes to temps next, and temps next changes to null, right? Both of these operations are done. Last operation says that if list 1 is not null, in that case temps next is equals to list 1, else temps next is equals to list 2. Now after this I will have to remove the original dummy node, right? And I will have to assign it to the new head. So list node star new head is equals to heads next. I will delete my head, delete your head, and now return your new head, right? Let us try to compile and run it. Hope it would work. It is working fine for the sample test cases. Let's try it for the backend cases also. So working fine. So thank you for watching and have a nice day. Please do consider subscribing and stay tuned for the more such videos. Have a nice day. Bye.